There is a wall that heats a room. No furnace behind it, no pipes running through it, no electricity feeding it. It absorbs the sun in the morning and releases that heat slowly through the night, long after the sun is set, long after the fire has gone cold, long after the temperature outside has dropped below zero. It has been doing this for 2,000 years. The Romans built it. The Anatolians built it. The cliff dwellers of the American Southwest built it and lived inside it for centuries without a single heating system. Then in 1945, America decided to build a different kind of wall, a thin one, a cheap one, a wall that held nothing, stored nothing, and required a furnace running on purchased fuel every single hour of every single winter to compensate for everything it could not do. We did not stop building thermal mass walls because they failed. We stopped because a wall that stores heat is a wall that does not need a furnace. A room that stays warm on its own is a room that cannot be metered. And a family that owes nothing for warmth is a family that cannot be billed. This is the story of the wall that heats itself. The building principle that outlasted every civilization that used it, and the industry that spent decades making sure your contractor never mentioned it. Welcome to Buried Build Files. Before we open this archive, if these forgotten techniques matter to you, the best way to preserve this knowledge is simple. Subscribe, hit the bell, and share these archives with those who need to remember what we forgot. The archive opens in the Anatolian Plateau, roughly 9,000 years before the birth of Christ. A settlement called Catalhoyuk sits on a flat plain in what is now central Turkey. No streets, no doors at ground level. The inhabitants enter their homes through holes in the roof, descending wooden ladders into rooms whose walls are made of sun-dried mud brick, 2 foot thick, packed tight, plastered smooth. Archaeologists who excavated the site in the 1960s found something that stopped them. The interior walls of these 11,000-year-old structures showed no evidence of continuous fire use. The hearths were small. The fuel deposits were minimal. Yet the structures were clearly inhabited year-round in a climate that drops below freezing for months at a time. The walls were doing the work. 2 foot thick, dense mud brick absorbs heat from the morning sun and from cooking fires. It holds that heat for hours. When the fire goes out at midnight and the temperature outside drops to 20 degrees Fahrenheit, the wall is still releasing stored energy into the room. Not as much as a furnace, enough to keep the occupants alive. Enough to keep the interior 30, 40, sometimes 50 degrees warmer than the air outside. This is thermal mass. Not a technology, not an invention. A physical property of dense material. Stone, earth, brick, concrete, and water all possess it. They absorb heat slowly and release it slowly. The denser the material, the more heat it holds. The thicker the wall, the longer it releases. A 12-inch rammed earth wall stores enough thermal energy to keep a room comfortable for 12 hours after the heat source disappears. That is the entire principle. Mass absorbs, mass releases. Time does the rest. The Romans understood this better than anyone who came after them. 500 years before Christ, Greek architects were already building with south-facing orientation, positioning their homes to capture winter sun through wide front openings, while thick rear walls stored that energy against the cold night. Socrates described the principle to his students, and it was recorded. The oldest surviving document on passive solar design is 2,500 years old. It still works. But the Romans turned the principle into engineering. They developed the opus incertum, irregular stone masonry set in volcanic pozzolanic concrete that combine the thermal mass of stone with the binding strength of lime. Walls built this way held heat differently from cut stone. The irregular aggregate created micro-pockets that distributed thermal energy more evenly through the mass. The result was a wall that absorbed heat faster in the morning and released it more slowly at night. The baths of Caracalla, completed in 216 AD, covered 27 acres. The heated rooms spanned more than 10,000 square feet. The walls were 20 feet thick in the core sections. A single fire fed hot air beneath the raised stone floor through the hypocaust system. The stone absorbed, the stone released. Thousands of bathers stayed warm in rooms maintained at comfortable temperatures through Roman winters, all from a fire that burned less fuel than a modern gas furnace uses in an afternoon. When the empire fell and the engineering knowledge scattered across Europe, the builders who inherited the rubble did what builders do. They looked at what was standing. They kept using thick walls. Not because they understood the thermodynamics, because the thick walls worked and the thin ones did not. For the next 1,000 years, every significant structure in Europe was built with walls between 18 inches and 4 feet thick. Castles, cathedrals, monasteries, farmhouses. The thermal mass was not incidental. It was the reason those structures were habitable before central heating existed. In the cliff dwellings of Mesa Verde, Colorado, the Ancestral Puebloans built into south-facing sandstone alcoves, using the massive stone of the cliff face itself as a thermal battery. The rock absorbed the low winter sun during the day, and it radiated that stored heat back into the dwellings through the night. Some of these structures were occupied continuously for 700 years. No furnace, no fuel, no bill. The principle was not a secret. Every culture that built with available materials in a climate with cold nights discovered it independently. Mass facing south, windows on the warm side, thick walls on the cold side. The physics does not change. The sun still rises. Stone still holds heat. Earth still insulates. Then in 1956, a French engineer named Félix Trombe and architect Jacques Michel took this ancient knowledge and turned it into a precise, modern system. They built a wall, dark-colored masonry, 8 to 16 inches thick, placed directly behind a pane of glass on the south face of a building, separated from it by a gap of roughly 1 inch. Sunlight passes through the glass and strikes the dark wall. The glass creates a greenhouse effect. Heat enters but cannot easily escape back through the glass. The wall absorbs that heat all day. By evening, the stored energy begins to radiate through the wall into the living space. Vents cut at the top and bottom of the wall allow natural convection to circulate. Warm air rises through the top vent into the room, and cool room air is drawn back through the bottom vent to be heated again. No fans, no pumps, no electricity, no fuel. A trom wall can provide 60 to 75% of a home's heating needs in the right climate. The sun does the charging. The wall does the delivering. And when the sun goes down, the wall keeps working for another 12 hours on stored energy alone. The principle was tested. It performed. Independent measurements confirmed the numbers. The Department of Energy studied it. The results were not disputed. Then oil prices dropped. Gas got cheap. The construction industry went back to doing what it had been doing since 1945. Building thin walls, installing furnaces, sending monthly bills. Here is what changed after 1945 and why it changed. The war ended. America needed houses, millions of them, fast. William Levitt had proven during wartime that houses could be built like assembly lines, standardized components, unskilled labor, rapid installation, Levittown, New York, 17,000 houses built in 4 years. The Levitt wall was not designed to store heat. It was designed to be built quickly. 2x4 lumber framing, half-inch drywall, batt insulation stuffed into the cavities. Total wall thickness, 4.5 inches. Total thermal mass, effectively 0. A 4.5-inch stud wall stores almost no heat. It absorbs the morning sun and warms through by noon. When the temperature drops at night, there is nothing in the wall to release. The interior cools immediately. The furnace fires. The meter turns. Levitt did not make this choice because thin walls performed better. He made it because thin walls were cheaper to build faster. The furnace was cheaper than the masonry. The gas line was cheaper than the mass. And the gas company would bill the homeowner every month for the rest of their life, which, from the perspective of the gas company, was a better outcome than a wall that needed no fuel at all. The numbers tell the story plainly. The global HVAC industry is worth $240 billion a year. The United States residential natural gas heating market alone exceeds $60 billion a year. Every home built with adequate thermal mass is one fewer furnace sold, one fewer service contract written, 0 monthly revenue from a family whose wall does the heating for free. A wall that stores heat is not just a construction choice. It is a threat to one of the largest supply chains on Earth. Building codes became the mechanism. The International Residential Code, the document that governs construction standards across all 50 American states, is written and updated every 3 years by the International Code Council. The ICC is a private nonprofit organization. Its voting membership includes representatives from the building products manufacturing industry. Its corporate members include the Portland Cement Association, the American Chemistry Council, the American Forest and Paper Association, the National Association of Home Builders, and the major drywall manufacturers. These organizations do not fund the ICC out of civic generosity. They fund it because the ICC's output determines what materials are legally required in American residential construction. The IRC prescribes minimum R values for wall insulation. R values measure resistance to heat flow, not the capacity to store heat. A material can have a low R value and extremely high thermal mass. Rammed earth, for example, has an R value of roughly 0.45 per inch, which is far below the code minimum. But a 24-inch rammed earth wall stores enough heat to buffer a 40-degree overnight temperature swing without any mechanical assist. The code does not measure that. The code does not have a category for thermal mass performance. It measures only insulation resistance, a metric that favors the materials manufactured by the companies that write the code. A builder who wants to use thermal mass construction must apply under alternative compliance pathways that require engineering documentation, additional plan review fees, and inspections by officials who may never have evaluated the technology. In most jurisdictions, the approval process costs more than the materials. The result is that the wall technology proven across 9,000 years of continuous use is effectively unavailable to any American who builds through the conventional permitting system. But some builders refused to forget. In Moab, Utah, a builder named Kalen Taylor has been constructing rammed earth homes since 1989. His first structure, a 2,000 square foot home with 24-inch rammed earth walls and south-facing glass, has maintained interior temperatures between 65 and 72 degrees through 35 winters without a furnace. The home has a backup wood stove. The kindling has not been touched since 2003. Taylor spent 4 years fighting the Grand County Building Department for permits. He was told repeatedly that rammed earth did not meet code. Not because the walls were structurally inadequate, because the walls were not on the approved list. He eventually obtained approval through an alternative materials provision that required 3 separate engineering certifications and a special inspection program. The total permitting cost exceeded the material cost of the walls themselves. He built it anyway. He has built 11 more since then. Every one of them performs the same way. Warm walls in January, cool walls in July. No furnace running, no bill arriving. The University of Bath published research confirming that rammed earth walls outperform insulated timber frame walls for temperature stability. The walls hold heat longer, release it more evenly, and buffer temperature swings that conventional insulation cannot handle. In 2023, the United Kingdom Building Research Establishment formally recommended thermal mass as a key strategy for climate adaptation in residential construction. The science is not new. It is 9,000 years old. The researchers simply confirmed what the builders of Catalhoyuk demonstrated, what Roman engineers perfected, what the Ancestral Puebloans proved in the cliffs of Colorado, and what Kalen Taylor has been building in the Utah desert for 35 years. A trombe wall can be added to an existing home for a few $100s in materials. South-facing glass, dark masonry behind it, vents at top and bottom, no contractor required, no permit in most jurisdictions, no monthly bill, ever. A rammed earth addition, a thick garden wall on the south side of your home, packed with soil from your own yard, costs nothing but labor and begins storing solar heat the day it is finished. The physics is not in dispute. The performance data is publicly available. The material costs nothing to excavate. The only thing standing between you and a wall that heats itself is a section of the International Residential Code written by people whose revenue depends on the alternative. We did not lose the thermal mass wall. We were told to build thin. An industry worth $240 billion a year does not allow alternatives to exist in public memory. A wall that stores heat cannot generate shareholder value. A family that warms itself from stored sunlight cannot be invoiced. So the codes measured the wrong thing. The approvals were designed to be unaffordable. The builders were handed a form that had no category for a wall that worked without fuel, and the knowledge was buried, not in the earth, in plain sight. In 9,000 years of standing structures that anyone could touch and press their hand against and feel the warmth still radiating hours after the sun went down. The physics has not changed. The sun still rises at the same angle. Stone still holds heat the same way it held it in Catalhoyuk and in the baths of Caracalla and in the cliff dwellings of Mesa Verde. The only thing that changed is who profits when you stay cold. Every home you have ever lived in was designed to need something you have to buy. That is not an accident. It is a business model. But the archive is open now. The knowledge is here. 2 feet of earth and a south-facing window. That is all it takes to build a wall that heats itself forever. If this archive opened something for you, subscribe to Buried Build Files and hit the bell. Every like and every share preserves what they tried to erase. The next archive opens soon.